Hello everyone, I'm Dr. Kanak Kalita and I welcome all of you to this new workshop. And in this workshop, we'll be starting with our first session, that is on the introduction to research. And a brief introduction about me. I did my PhD in the aerospace engineering and applied mechanics department from Indian Institute of Engineering Science and Technology, Shibpur, India, from which I did my master's also in 2014. I am a very active researcher, and so far I have published around 28 SCIs, around 43 Web of Science, and around 53 Scopus. To find more about my research interest and my current ongoing papers and all that, you can visit my website, which is given here. Now, basically, let us start with what basically is research. So, when we say research, research is basically a systematic approach. That is what we have to understand first. That research is not something that you wake up one day and you do it out of the blue. It is a systematic process, and that you build this systematic process and you develop this systematic process over. It may range days. It may range depending on the type of research that you are doing. It may range into days. It may range into months, or it may range into even years. Okay. So again, when we do this particular activity, which we are calling as the research, it must have a proper approach. Okay, because the outcome of the research is something that has a wide societal importance as well as wide scientific community importance. Okay, so that is why when the research that we are doing, or the approach that we are using, is equally important as the topic itself. Now, so if you have to describe the research, we can describe it as the research is the systematic investigation into the study of the materials, sources, etc., in order to establish facts and to reach new conclusions. It is basically an endeavor to discover new and collate the old facts by scientific study of a subject or by the course of critical investigation. So what we mean by this is that many of the times what we do is that when we are doing a particular research, we are trying to find something which is not there, or which nobody has discovered till then, till that point of time. We are trying to do that, and at many times we are also trying to establish the already uh, the already established laws, or already proposed laws. We are trying to establish them by carrying out additional experiments or carrying out additional studies. Okay? So that is the entire crux of the research. Again, the research is meant to be something which will solve a particular problem or a particular question that has been raised on a particular topic or a particular domain. In many of the times, it may happen that we may already think that we know the answer to the question which we are dealing with, and sometimes the answer even may be very obvious, or it may be common sense. But even those kind of questions also, or even those kind of problems also, need what we call as the research, or it needs more scrutiny, or it needs more scientific scrutiny in that to establish it, right? So a lot of the times what may happen is that the science or the theory behind a particular phenomenon or a particular problem that we're studying, it may be very evident, and it may be in fact it may be very common folk, in the sense that it may already be known uh, in the general public, in terms of uh, uh, in terms of uh, in terms of it may be a well-established law, or in terms of it may be something that has been already been carried out. But still, when we investigate it from a research perspective, or from a research-oriented framework, what we intend to do is that we intend to study it in a very holistic manner. Okay, we intend to study it in a very uh, rigorous and a very comprehensive manner, so that the knowledge that we have to gain from this work, or the knowledge that is already evident from this work, it may be already evident. In many of the cases, we already know the answer to the research that we are conducting. So this research can be done if we do a very rigorous scientific scrutiny, or a very rigorous scientific study, and then the knowledge that we generate will have more importance than just guesswork, because now you have some proof regarding why this is happening, and you also have some evidence backed research, right? That is what we need. Next, so what is the basic idea of doing the research is that you have to initially, your first priority is to formulate your question. Okay, what is your research question that you have to formulate? Again, when we say about research, the scope of the research may be very limited in the sense that it may be something that you are doing in only one particular paper, that the entire research work is kind of can be summarized in form of only one research paper. It can be very small in that sense, and at times research can be very large in the sense that it may take 4 or 5 years, and uh, it may be represented in form of a PhD thesis or something like that. And at times it may be very very large. For example, it may be something like what the CERN labs or what the marine biologists and all these people do. They carry out research for 20-25 years and so on. And at the end of the research, they get some kind of information out of it. And generally what happens is that if you look into all those kind of studies that take like 20-25 years to complete, you will see that the entire research work is so huge that it itself, from this entire research itself, they may have multiple PhDs that are coming out from the research itself, okay, over the period of the 20-25 years. So in that sense, the scope of the research is very dependent on the type of the problem that you're addressing. As I told, it may be something that you can carry out in a few weeks if it is something that can be easily summarized in a particular in one particular paper, and it can be something that have a mid kind of range, it's like your master's thesis or like your PhD thesis, and it can be something that is very very large, which may be the continued effort of like multiple PhDs over an elaborate period of time. Now, to figure out how you are going to answer it, and you need to uh, you need to have some kind of idea regarding how you are going to answer the problem that you have posed, or answer the problem or the question that you have posed, because that is the first part, right? The first part is to formulate the question, and the second part is to figure out that how are you going to answer that particular question. And when you do this, you do something called literature review. And in the literature review, basically what you see is that how others have answered it. Is there anyone else who has answered that particular research problem? And if he has done, then how he has done it. Okay. And if nobody else has done, then you look for remotely connected problems, like problems which may be vaguely related to the problem that you have taken, and then you look into how those problems were solved, and from that you can get some kind of idea, or you can get uh, some kind of additional information regarding will this approach be worth it, or will this approach, is this approach that you are going to use, was it used by somebody else, or was it not used by somebody else, or if nobody has used it, then why they have not used it, is it very difficult, or is it a not, is it a non-reliable method and all that. Okay, so you get all those information from the literature review. And how does your proposal fit into what others have done? This is also something you need to analyze. And this literature review also gives you some answers regarding that how you will how you are going to know that you have answered it, because by reading some of the literature review, you get an idea that is the uh, is the problem that was proposed by this particular researchers, have they answered it by the end of the paper or by the end of the thesis, have they answered it, and if they have answered it, then how they have convinced the reader that they have answered it. This is also something, a very important part of the research itself, and this is something that you need to inculcate, and this is something that you develop over time. Next thing is that once you conduct the research, or once you figure out that how you are going to tackle the particular problem, then the next step is then you have to think of how you are going to present your solution, and how do you present your solution. That is the next part. Now, there are different kinds of like research that are conducted. So among them, one of them is like the classical scientific method. So here, basically, what you do is that you observe a particular phenomenon, and sometimes it may be systematic, it may be occasional, or it may be accidental. You observe that particular phenomenon, and from here, this may be related. This may be like correlated with the first question that you have. Okay, that how do you formulate your question? Okay, so once you make some observation of some phenomenon, it may be systematic, it may be occasional or accidental. And based on that phenomenon, what you can do is that you can formulate your research problem. You can come up with a research problem. Next, when you come up with your research problem, as I told, the next thing what you do is that you read some literature, or you discuss with your collaborators, or discuss with your co-authors, or your co-project investigators, and then you come up with some kind of a hypothesis or an idea of an explanation, right? And when you come up with this hypothesis, you it may involve multiple things. It may involve reading from the already existing literature, getting some idea from already existing literature, or it may involve some kind of intuition, or it may, so at times it may also include some kind of guesswork. Okay, now how do you know that which will work? Again, the only possible way to find that out is by doing some experiments. Okay, what I mean by experiments here is that if it is a problem that is related to social science, then probably for you the experiment may be like collecting the relevant data by means of questionnaire and all that. If it is something from the experimental sciences, you may like to carry out some experiments in the laboratory. Or if it is like basic sciences where you need to carry out experiment in the actual condition, you carry out some experiments in that condition, and then you find out, you go and eliminate the invisible solutions, in the sense that if you have made some guesswork, you eliminate. If you are not able to prove that guesswork, or if there is some intuition that you have, you eliminate them if you are not able to prove that intuition, right? This is how the hypothesis works. And the next thing is that you test the hypothesis. Okay, what do you mean by testing the hypothesis? Is that just collecting the data and just having the hypothesis is not enough. You need to back it up with credible data. Okay, what I mean by with, not just with credible data, at the same time you need to back it up with credible analysis. Okay, what I mean by analysis is that when you have the data, it may be from the social surveys that you have conducted, or it may be from the experiments that you have conducted in the laboratory or in the actual environment. And then what you do is that you make some additional analysis on that. It may be like statistical test that you do, or it may be like any additional test that can prove the efficacy of the results. At the same time, it may prove the reliability of the results, because the reliability of the results is equally important. Because in a lot of the cases, what happens is that if suppose say you are doing some certain simulations. For example, let me take a very common example, or a common numerical approach that I generally use in my research, that is called the finite element approach. Okay, or the finite element method. So there are a number of softwares that are available for finite element method. Like the most popular among them is, suppose say, a software called ANSYS. So in the ANSYS, what happens is that if you given certain conditions, or if you input a particular research problem, or if you input a particular problem there, and if you give some certain conditions, and if the inherent steps, the basic steps that are needed to solve that problem, if they are correct, you will end up getting some results, right? You end up getting some results. You'll end up getting some beautiful graphs and all that. Okay, but at the end of the day, it is for you, or it is for the researcher to validate that the results that he is getting is accurate. Okay, especially in the case of numerical analysis, this is very important, because in the numerical analysis we have this term called GIGO, or garbage in, garbage out. So if you faultily given wrong kind of inputs to your experiment, then you are going to get some faulty kind of results. And it is for you as a researcher to find out, based on your intuition, based on your training in the area, based on your domain expertise, and based on your additional research that you have conducted, to find out whether the results that you have got is validable, or whether they are valid or not. Okay, there are multiple ways in which you can validate your results. You can conduct additional experiments, and then you can correlate your numerical analysis with the experiments, or maybe you can test your experiments, or maybe you can compare your study with someone else who have already conducted it. Or at times, what you can do is that you can very elaborately write the methodology that you have carried out in this particular approach, and then you can discuss with senior people in the field to find out if the test approach, or if the methodology that you have used is correct or not. So this is how generally you test your hypothesis. Okay, and when you test your hypothesis, what you do is that you use a lot of additional tools like the statistical analysis and all that, to further bring weight or to further bring credibility to your results. Okay, because at the end of the day, for example, if most of you, if many of you are from the experimental sciences, right? So in the experimental sciences, you know that whenever we carry out some experiments in the laboratory, we do not just do it once. Okay, we do not just do it once. We repeat the experiments, especially I would say in my field of the engineering sciences. Whenever we carry out some experiments in the lab environment or in the laboratory environment, we carry out it at least 3 times, and then we report the findings of the three independent runs for the same problem. Okay, maybe we give the mean value of that particular problem along with the standard deviation of the problem. Why do we do that? Because it is a widely accepted fact, and in fact, it is a known fact that any experiment or any experiment that we conduct, any physical experiment that we conduct, is going to come up with some additional uh, is having some inherent errors in them or having some inherent bias in them. Okay, and how do you eliminate these errors and the bias? By conducting the experiment multiple times and then accounting for any kind of experimental error that is there in your approach or in your data, right? So that is why we conduct the same experiment multiple times to rigorously understand and to rigorously analyze the data, so that we can claim that we have done it multiple times, and by doing the multiple times, we are basically improving the reliability of the results. Because even after multiple even after multiple independent results, or even after multiple independent runs, if you are getting the same result, it means uh, the data is perhaps reliable. Okay. Next, what basically the hypothesis is, and how do you deal with this hypothesis? So basically, it is basically the probability of research, and in the research we have something called the probability, because as I already told in the previous example of carrying out experiments in the laboratory, that nothing is certain. You are not going to get the exact value, no matter how precise instrument that you have. If you repeat the experiments, you are bound to get some kind of you're bound to get some kind of fluctuation in the results. You're not going to get the exact same result that you got in the trial one. Okay, and generally, what happens is that there are certain, especially from the field of chemistry, you know that that exception that proves the rule, right? They know this theory, right? And then the scientific truth is actually usually a statement of what is the most probable given the current known data within the given framework, right? So basically, in the hypothesis, what we do is that we bring forth, or we present the idea that we have and the probable reason for the phenomenon, or for the problem to behave in that way, and then we try to prove that by using additional techniques. Okay. Next, what we do is that, as I already told, we use a lot of statistical techniques to try to show to some degree of confidence that the results that we have support the hypothesis that we have put forth. And then, what exactly a hypothesis is? A hypothesis makes a prediction of the expected outcome in a given situation, right? Usually, how the manipulation of the independent variable with the influence of the behavior of the dependent variable. Uh, generally speaking, in most of our experiments, we have something called the independent variable and something called the dependent variable. Okay, so independent variable are those variables; those are not reliant on any other variables. They do not depend on any other variables. Okay, means changing means the individual independent variables are those that you can alter, and if you alter them, then in the uh, suppose say you have a set of 5 independent variables, right? If you vary the value of one independent variable, then it should not affect the outcome of the other independent variables, right? That is generally uh, one of the uh, um, one of the preconceived or one of the prerequisites of having independent variable. And again, then you have something called the dependent variable. The dependent variable is something which is influenced by the independent variables. If you change the values of the independent variable, then the behavior of the independent variable will also change along with it. Now, the hypothesis is tested with the help of an experiment. An experimental design ensures that you are doing it in a genuinely and responsible way. What basically experimental design is that, again, if you are conducting some kind of survey, suppose say, let me start with social sciences. If in the social sciences you are conducting some kind of survey, you know that you go for something called the randomized trial and the stratified sampling and all those kind of sampling. Why do you need to do all those kind of sampling? Why can't you just choose 10 persons that you know and just get the information from them and then conduct your research? It is because whenever you are conducting a particular research, you have to, especially I'm talking now from the point of view of the social sciences. So whenever in the social sciences, whenever you are collecting some data, okay, whenever you're collecting some survey data based on some questionnaire, you want that the people from whom you are collecting the answers to that particular questionnaire, they should be a proper representation of the entire population for which you are going to uh, conclude. Okay. For example, if suppose say I have a research problem like uh, the number of the number of the number of the suppose say, if suppose say, again, this is just an hypothesis that I'm making. I do not know whether it is true or false. I'm just making this statement that suppose say you say that the number of the people affected in the rural areas by the COVID is less than the number of the people uh, in the urban areas, and then you go on and say that my hypothesis is that people from the rural areas have better immune system as compared to the people from the urban system, okay, maybe you are comparing the people from, suppose say, a very remote village in suppose say in the northeast. Okay. Suppose say you are comparing with someone from a very remote village in the northeast to someone uh, to the population of, suppose say, Delhi. Okay. a very a very populated state, at the same time a state, a very populated city, sorry, at the same time a city that is like plagued by a lot of problems of like uh, pollution and all that. Okay. So you go on and make a statement that people from this remote village have better immune, are suppose say a village from Manipur, you just say that people from this village in Manipur are more immune to COVID as compared to the people from Delhi. Okay. When you make this statement, now how do you justify this statement and how do you carry out the experiment? Okay. Now, to justify this hypothesis, if this is your hypothesis, okay, this may be concluded as a hypothesis. If you say that this is my hypothesis, then to validate this hypothesis or to prove the hypothesis, what do you need to do? You need to carry out some experiment. What experiment you need to carry out? You need to test, suppose say, some people from that particular village in Manipur and test certain people from Delhi. Okay, you need to take some blood samples, or maybe you need to take some uh, you need to look into some facts. I don't know. I'm not from biology. I don't know what you look at, but you look at you collect the blood and maybe you look at some kind of uh, you run some kind of test, and with those tests you try to validate your results. Now, this is where the experimental design comes in. Okay, so if suppose say I go and collect only the uh, uh, the specimen or the blood sample from the people from that particular village in Manipur. And when I am collecting the blood sample from the people, I am collecting only the blood sample of, suppose say, people who are from the age of, uh, suppose say, from the age of 25 to 35 in Manipur. At the same time, when I'm collecting the blood sample from the people in Delhi, I'm collecting the blood sample of only, suppose say, people who are from 40 to suppose say 50. Okay. Now, if I'm going to compare this, then this is a erroneous kind of study that you have done. Why? Because your hypothesis is on the entire population. Here, who is the population? The population of Delhi is your entire domain of the research. At the same time, the people from that particular village in Manipur is your entire domain of your research. Now, since you have collected the samples, or since you have uh, collected the data or collected the blood samples from a very limited number of people from within that particular population, it is not a proper representation of the population itself. Because when I was telling you about the village from the Manipur, I told that you've collected maybe from only 25 to 35 years old. Whereas in the village, there may be people who are much uh, much elder in the age, who are maybe 60 plus or so on. There may be some infants and so on. So what you have to do is that to have a proper experimental design, you should conduct experiments in such a way that you do not select the people in a very you select the people for the experimentation in a very random way. At the same time, you collect the blood samples from, suppose say, from people of different age groups, from different gender, from different stratas of the society, in the sense that some may be living in the slum, some may be very rich, some may have access to proper healthcare, some may not have access to proper healthcare. So you collect samples from all of them, okay? And suppose say you collect 100 samples from all of them. At the same time, you do the same thing for when you collect these samples from Delhi also. You collect the samples from different stratas of the society, from people who are from, suppose say, ranging from the infant to very old, okay? And when you do this, then it is a proper study, because now the sample that you have collected, or the blood, or the experiment that you have done on the blood sample that you have collected from these people, is now a proper representation of the entire population of Delhi, or for that particular village in Manipur. Because now you can, now whatever the research that you have done based on this kind of a study, you can make the claim about the entire population, because you have genuinely considered all stratas of the people who are living in the society, at the same time all gender groups, all age groups, and so on, right? So in that sense, that is a proper study. But if in the first example that I gave you, if you collect from, suppose a very small population group of 25 to 35, or maybe from 40 to 50, then it is not a proper representation of the entire population, and that is why the results that you are going to have from this particular study would be erroneous, okay? And then of course you have a lot of variables that you need to control, okay? There are a number of extraneous variables that are there, which you have to control in your hypothesis, because as I told you, the variables that you have demarcated is in the terms of independent variables and suppose dependent variables, okay? So what are the independent variables and dependent variables that you have to fix before you start the data collection, or before you start the experimentation? And at the same time, you also have to account for something called the extraneous variable, or sometimes we also call them as the noise variables, or sometimes we also call them as the extraneous variables. So this must be controlled so that they do not have any undue advantage or any undue influence on the experiment that you are going to conduct, or the experiments that you have conducted. Next comes the experimental phase. Here what you do is that if the experimental works, then the hypothesis is shown to be probably correct, okay? But you remember that you can never prove it to be 100% truth. This is the same reason why you see in a lot of ads that most of the ad companies, for example, related to like killing of a particular germ, you say that this, you see in the ads that this particular soap is 99.9% effective. No one claims it to be 100% effective. And this is exactly the reason why, because the amount of the sample needed to prove it to be 100% is in fact infinite. Means you can prove it to be 99.9999% truth, but you cannot prove it to be, but generally you cannot prove it to be 100% truth, okay? Especially in the field of experimental sciences, okay? That is why generally in a lot of these ads, you see that the claim that it is 99.9% effective and so on. This kind of claims are made, right? So if the experiment works, then the hypothesis is shown to be probably correct. We cannot say that it is definitely correct. We cannot say that, of course, because we cannot prove it to be 100% true. But if it fails, if the experiment fails, then it may be because that the hypothesis is wrong, or it may be because the experimental design is faulty and so on, okay? Now, what is basically a null hypothesis? This is something that you hear a lot in your research. So basically, what is a null hypothesis? So experiments are generally set up to demonstrate or support a hypothesis, right? So you have to remember that I have used the word here as support and not prove. So generally, when we carry out some experiments, as I already said in the last example, that it is very difficult to prove something with 100% confidence. But at the same time, it is easy it is easy to support a particular hypothesis with suppose say 95% confidence or 99% confidence. Means it is relatively easier. Okay, that is why we generally use the terminology as support or to demonstrate a hypothesis. Okay, demonstrate or to support a hypothesis, because it is easier to support a hypothesis and rarely we can prove a hypothesis. Okay, because the amount of the analysis that is needed to exactly prove a hypothesis, that is like 100% effectiveness of the hypothesis is almost impossible. Okay, so the null hypothesis is generally we refer to it as the H naught, H and a suffix of small 0. Okay, so this is known as the H naught or the null hypothesis. The null hypothesis is that any observed change in the behavior are due to chance. Means these are due to like these are like random mechanisms, and this has nothing to do with our hypothesis. Okay, that is what the null hypothesis says. And the alternate hypothesis or the H1 is generally the hypothesis that you are trying to prove. So generally, how does it work? You do not try to prove the alternate hypothesis. Rather, you try to disprove the null hypothesis. Okay, you try to disprove the null hypothesis, and by doing that, you try to support the H1 hypothesis. Okay, so usually the best you can do is refute the H naught, thus showing that H1 is probably correct. Again, whenever we are using the word hypothesis, then always you will remember that we have something called the statistical significance or the confidence bands or the confidence intervals. Generally, these are like 95% confidence intervals or 99% confidence intervals and so on, right? So in the case of the germs, the soaps that kill germs, the example that I gave you, they use something like 99.9% confidence bands and so on, right? So next, where do these hypotheses come from? Okay, they do not come from thin air. Means they do not. You cannot just go on and propose a hypothesis. Okay, they come from within a framework. And how do you define this framework? So some phenomena is not well explained by the current thinking. So then you go on forward and then you give a particular. Then you go and give a particular idea that this might be reason why this particular phenomenon is behaving in this and this way, or that why this particular phenomenon is showing. You give forth a new hypothesis, and then you try to prove or disprove the you try to prove the hypothesis, or you try to disprove the null hypothesis. Okay, and then this is how the research with hypothesis works. Again, in this terminology, you have probably heard about theses, you have probably heard about antithesis, and you have probably heard about synthesis. Okay, so what are these? What are these theses, antithesis, and synthesis? Right. So thesis is the original statement of an idea. Okay. So generally, this is why we generally refer to our PhD as PhD thesis and all that, because it is generally original statement of an idea that we are going to have, or that we are going to trying to prove. Right. At the same time, what is an antithesis? Antithesis is an argument to challenge the previous thesis. Okay. Suppose say if there is an existing if there is an existing hypothesis, if there is an existing widely accepted hypothesis, to prove that you carry out some experiments, you collect some new data, you carry out some experiments, and then you do some statistical test on them, and you prove and you disprove the existing thesis or existing hypothesis. Then this is what we call it as a antithesis or a antithesis, right? Next, what do you mean by synthesis? Okay, synthesis. Okay, so the synthesis is basically a new argument from the existing sources. Typically, it resolves the apparent contradiction between the thesis and the antithesis. Okay. Now, what is testability? Testability is something that is very, very important from the research point of view, because a good hypothesis is always testable. Okay. So if you are proposing a hypothesis, it should be testable. Means if it is not provable in the sense of shown to be true, or true here it means true means certain, and refutation of a thesis by proving that it is false is the cornerstone of the entire modern science, right? So simply refuting a thesis is okay, but better science will explain why the thesis is wrong, and better still offer a alternate hypothesis. Okay, that is exactly what we try to do in the modern research. Whenever we are trying to prove a hypothesis, if there is any existing hypothesis in that particular work, we try to disprove it, or we try to prove that this particular new hypothesis that we have proposed is better than the existing one, and we give some reason for this. Okay, a sound science is one which gives proper reason for this. Of course, you have the data which backs your claim that your current hypothesis is better than the previous hypothesis. Okay, you have the data to back that, back your claim. At the same time, you have the results from the statistical analysis that you have carried on the data to back your claim. But at the same time, it is important to give some kind of explanation that why the earlier thesis hypothesis is wrong and why the existing thesis is better, or why the new hypothesis is kind of a better understanding of the phenomenon. Okay, that next, in this regard, we have different kinds of hypotheses. We have one-tailed hypothesis and two-tailed hypothesis. Now, strictly, we are going into the area of statistical terminology. So, so what is one-tailed hypothesis? So the statistical significance means expected results are found, and in the two-tailed hypothesis, only need to show that they are different and the results are statistically different. Okay, so this is the difference between one-tailed hypothesis and two-tailed hypothesis. Okay, so it again depends on the kind of research problem that you have, and on the kind of the expectation that you have, or the conclusions that you want to derive from your work. Based on this, you either go with a one-tailed hypothesis, or you either go with a two-tailed hypothesis. Of course, you know about the variables. We have talked a lot of a big deal about the variables. So variables are the experimental measures of the behavior of the what are basically variables? Variables are something that control the entire mechanism or the entire phenomenon. Okay, by quantifying for the variables, or by kind of having a measurement for the variables, or by kind of accounting for the variables, what you can do is that you can predict the entire, or you can control the entire dependent variable, or you can control the entire phenomenon itself, right? If you understand that, if you understand the intrinsic behavior of the independent variables, and how the independent variables interact among themselves to alter the dependent variable, then basically what you have done is that you have understood the entire phenomenon, right? This is why you see that in the modern times, with the use of a lot of technology, like lot of new technology, and lot of new methodologies like machine learning and all that. At all points of times, what we are trying to do, what we are constantly trying to do, is that we are constantly trying to map the dependent variable as a function of the independent variable. Okay, for example, let me give you an example. If suppose say you want to work on the spread of the, suppose say you want to work on the spread of the COVID, right, or the coronavirus. Okay, so for this, what do you know that what are the dependent variable? What is the dependent variable here? The dependent variable here is a binary kind of thing. Either you can be affected, or you may not be affected. Okay, so if suppose say you are affected, it is 1, and if you are suppose say not affected, it is 0. Okay, means are you affected? The question for the dependent variable may be, are you affected? So the question can be a binary thing, yes or no. Okay, so suppose say that is the dependent variable. Okay, are you affected? That is suppose say the dependent variable, means it can be yes or it can be no. Now, what is the independent variable? What are the variables on which it depends? It depends on a number of facts. It depends on the number of facts, like how good is your immune system, or is your immune system developed enough to counter the effect of the virus? That could be one variable. The second variable could be, have you come in contact with anyone who is probably a carrier of that particular virus? That could be another factor. There may be so many other factors. Okay, have you recently been? Means there can be like numerous factors. Okay, so now when you develop a particular correlation, or when you develop a particular relation, not correlation, excuse me, not correlation, a relation or a functional relation between the dependent variable and the independent variable. So basically, if you are able to accurately map the dependent variable as a function of all the independent variables that are involved, you have solved your entire problem, or you have accounted for the entire phenomenon. For example, let me give you another example. For example, suppose say you want to uh, mm, okay. Suppose you want to machine a particular product. Since I am from mechanical engineering, let me give you that example. Suppose you want to machine a particular product. You want to increase the suppose say the material removal rate, okay, or the increase the productivity of a machine. So what are the options that are available to you? You may increase the speed of the operating speed of the machine. That is what we call as the spindle speed, or you may increase the feed rate. Okay, that is how much material you are pushing forward for cutting. Okay, you may increase that. There may be uh, additional kind of parameters also involved. Suppose these are the two different parameters that are involved, and your dependent parameter is amount of material removed, and your independent parameters are the spindle speed and suppose say the feed rate. Okay, so if you are now able to correlate, again I'm using correlate, not correlate. If you are able to uh, relate, or if you are able to build a functional relationship between the material removal rate and the spindle speed and the feed rate, essentially what you have done is that just by putting in a different value of the feed rate, or by putting in a different value of the spindle speed, you will be able to predict the amount of the uh, material removal rate that is going to occur in the machine. So essentially what you have done is that you have understood the entire phenomenon, or you have understood or you have accounted for all the variables that are there involved in that particular phenomenon. Okay, so in simple words, what basically we try to do is that we try to understand the behavior of the independent, we try to understand the influence of the independent variables on the dependent variable, so that we can account for the behavior of the dependent variable, right? Next, this brings us to another important topic of quantitative versus qualitative research. So what is quantitative research? Quantitative research is again systematically we observe the changes in the phenomenon of interest while manipulating what are believed to be causal informations. Okay, and what is qualitative research? Qualitative research is concerned with the individual's personal experiences of the problem under the study. Again, quantitative research is generally easier to conduct as compared to the qualitative research. Qualitative research takes a lot of time, and quantitative research is always backed by some kind of data and by statistical test and all that. Okay, that is basically the quantitative research. And qualitative research generally are those which generally take a lot more time, and these are a little difficult to prove, or these are a little difficult to conduct. Next, what we have the proof by demonstration. So what do you mean by proof by demonstration? Intuitive alternative to the classical scientific method. By build something specific and then claim that it can be seen as an example of a more general class of the solutions. And we have high risk. Okay, it's difficult to demonstrate generalism, and in fact, doing so entails making a posteriori hypothesis. Okay. So what do I mean by proof by demonstration is that whenever you are trying to put forward a hypothesis, and then you are going to claim that this hypothesis work, or this is exactly how this phenomena behaves, or this is why this phenomena behaves, then you need to demonstrate it, or you need to prove it by uh, carrying out experiments. That is exactly the proof by demonstration. And this brings us to the last slide, or the last topic of this particular session, where we deal with the planning of the research. Again, here I'm going to talk about it in a very small context, or in a very in just 2 to 3 minutes. But on this, we have an entire session lined up where we'll talk only on the entire planning, and how to collect the data, how to analyze it, and all that. Okay, so as I already told in one of the previous slides, that how do you plan your research? You plan your research by putting forward a research question that is nothing but your statement of the problem. Then you carry out some kind of literature review to find out whether anyone else has tackled the problem, and if they have tackled the problem, then how they have done it, what are the lacunas in their particular work, and if they have not done it, then why they have not done it, and how do you find out why they have not done it? By studying related work. Okay, something that is related to your work. At times it may be like very strongly correlated to your work. At times it may be kind of a vague correlation with your work. You study those, and by studying those you get an idea that why this problem was not taken, uh, or is it relevant, or is this particular problem worth tackling, or is this problem worth is this relevant enough to be tackled, and all that kind of answers you get from the literature review. Then of course you have the choice of the research method. What do I mean by the choice of the research method is that what kind of methodology are you going to use? Are you going to use qualitative research? Are you going to use quantitative research? Are you going to this could be one of the choice that you make. Then again, there may be additional choices like if you are saying that you are making a quantitative kind of research, then in the quantitative research, are you going to go for experimental backed research, or are you going for physical experiments? Are you going for numerical experiments, and so on, right? And then you design the entire study and you collect up the data. And when you collect the data, when you do the what do you mean by design of the study is that again the design of the study is something that is very important, because as I told you in the COVID example a little while back, that between the two places, a place in a village in Manipur and people from Delhi. If you remember that example, so the design of the study is very important. How do you design the study? How do you collect the data? That is again an example that I gave from the social sciences background, or maybe from the experimental sciences only, but that involves some kind of social interaction, right? If you are thinking it from a engineering perspective, or from uh, uh, a perspective of experiments that are conducted in the laboratory. For example, if you remember a little while back, I was telling you about how you can map the material removal rate of a particular machine with respect to the spindle speed and the feed rate. Of course, when you have a machine, suppose say the number of the available speeds that are available in the machine in terms of the spindle speed or the feed rate, they are there are a number of different speeds that are available, right? Maybe one of the machine operates from suppose say 100 to 1000, okay, and suppose say the feed rate ranges from suppose say zero point 0.1 to suppose say 100 mm per second, okay. So how do you deal with all this? So how do you decide that uh, on which particular setting do you collect the data? So to do all this, you have something called the design of experiments, and you have something called the experimental design. Okay, essentially you cannot go and do some random experiments and you collect the data and you say that okay, this is what my data says. No, you cannot do that. So to collect the data also, you need to have a proper design of the study. You cannot arbitrarily collect the data from on a particular number of on some arbitrary number of settings. You need to properly plug in the values into a proper statistical system that we generally in the experimental sciences we call it as the DOE, or the design of experiments. There are different kinds of methodologies that are available. There are methods like the full factorial design, or the central composite design, or the box banking design. In fact, we have designs like we have more improved designs like Latin hyperskew and Halton scheme, or the Sobol sequence, and so on. Okay. And next, once you carry out or once you design the study, then you collect the data and then you analyze the data. Of course, when you analyze the data also, you have so many different options available before you. When you analyze the data, are you going to use a machine learning algorithm? For example, are you going to use a machine learning algorithm, or are you going to use a simple regression, or are you going to use a complicated regression by using some kind of machine learning based algorithms like neural network and all that? So this is just one example that I'm giving you of the analysis of the data. Similarly, you have to decide that whether are you going to carry out one tail test or two tail test, and uh, all this kind of decisions you have to take. And how do you make all these decisions? You make all these decisions based on the end product of your of your uh, of your research. That what do you want to conclude? Okay, based on that, you decide that which particular method would be the most appropriate, and then finally you come up with the write-up where you write down the entire thing in terms of reports, or in terms of thesis, or in terms of papers, so that this can be now be spread among the scientific community, and this may be this may be beneficial to the other people who want to work on the particular area. So with this, we come to the end of this introduction session. Though it was a lengthy session, but it was a session where we tried to touch upon all the points that are involved in the how to do research theme, right? So basically, it was the introduction to research where we talked about all these different kinds of themes. All this, if you look at all these kind of slides that I have here, instead all of these slides can be like one session in itself, because the amount of information that is there in all of these slides is so vast. Nevertheless, we have tried to condense all of this information in one session, and I hope that this session is a good introduction for you. And from here on, you can go into some more specialized kind of information, and then you can start learning about them. Thank you for being such attentive audience.